textbook. The example at the top here is not in the textbook. All right, looking at this example, we're asked to factor it. If we're asked to factor it, we need to find the common factors and pull it out, the GCF. Well, this whole binomial here in parentheses, that's multiplying the 4x. This whole thing in parentheses is multiplying the 3. So this is a factor of this first term, and this is a factor of the second term. This and this are both the same, aren't they? They're both 5x minus 3. So those binomials there, that binomial is a common factor between the two terms. So we can factor out that common factor. So we're going to start off by putting that common factor, the GCF, outside of there, 5x minus 3. That's the GCF of the two terms. What's left in this first term after I pull out the 5x minus 3? Anybody? 4x. Just the 4x. So we're going to have a 4x there. And then what's left in this term after pulling out the 5x minus 3? 3. And it's a plus 3, right? So we're going to put a plus 3 on here. What I've done is I pulled out that common factor from both terms, and this is the factored polynomial. Does anybody have any questions about that? Another way to look at it, just to show you, is if you temporarily say that a is equal to 5x minus 3. That's the same as saying, this would be saying 4x times a plus 3a. When you go to factor this, you can see they have a common factor of a. So we pull the a out, you're left with just 4x plus 3. Now I bring this 5x minus 3 back in for a, and I'd end up with this two binomials as a factored set. Okay? So let's look at the questions 12, 13, 14, 15 here. Number 12, is this the same as this? When we factor it out, we talk about dividing that term by the 2x plus 3, right? So we're going to divide this by 2x plus 3. Did we talk about that in class yesterday? Talk about dividing by the common factor to pull it out? All right. So that means the 2x plus 3 will cancel here. The 2x plus 3 will cancel here. When I say cancel, what does it actually become? When you divide something by itself, the value is 1. So we're going to have that 2x plus 3 as one of the factors. The other factor is going to be what's left in here. What's left in this term? 7x. What's left over here? Well, we said that's going to become a 1. So plus 1. It's one of the trickier parts. A lot of students have trouble seeing that this is a 1. All right, number 13. Do we have a common factor with that binomial? Yes. So we're going to write that binomial, x plus 2. That's the first factor. What's the second factor going to be? Can anybody tell me? Ariana?
Negative 4x plus 9.
Negative 4x plus 9. And you were out yesterday. Good. You're getting it.
Would that be the answer?
This would be the factored answer, yes.
Okay.
All right. All right. Number 14. Is this the same as this? No. Is there any way I could rearrange this to make it the same as this? No. 2t, 3t, there's definitely nothing we can do with it. There is no factors. This cannot be factored. Cannot be factored. If you can read my handwriting here. I hate these stylus pens. But anyway, the last one here, t plus 6 and 6 plus t. Are they the same? I hear people saying yes, but one of them's got t plus 6, the other one's 6 plus t. How can they be the same? the commutative property of addition. It doesn't matter whether you write it as t plus 6 or 6 plus t. These, if I divide this side by t plus 6, it's going to end up canceling with that. Divide this side by the t plus 6, it'll cancel with that. So I will end up with, parentheses, t plus 6 and 5t minus 8. Okay, they like to do this kind of switch around thing here, so you got to be aware of that. Can you do the same thing with subtraction? Now, if this was t minus 6 and 6 minus t, this would not be factorable. All right, to factor this one by grouping, you need to create two groups. So you're going to take the first two factors and the second two factors, and the middle, you're always going to make it a plus. If it was a negative, carry the negative over into that first term over here. Okay? When you look at these as two separate pieces, make that a plus. Just carry whatever, if it's a negative, carry that sign to the first term there. Okay, so I've created two groups. So I've got 3x cubed minus 15x squared. I'm going to look at that one alone first. What common factors do you see between the numbers there? Troy? 3. Is that the GCF? For the numbers at least? Yeah, for the numbers, yes. What about the variables? What's the GCF for the variables? X squared. Remember, it's going to be the lower of the two exponents. When they have the same variable, it's going to be the lower of the two exponents that has the GCF. So we end up with 3x squared as our GCF. What's left of 3x cubed when you divide by 3x squared? What's left of this when you divide by this? Jade? What? Almost. Look at the exponents you have an x to the third and x squared. When you divide by like bases, what do you do with the exponents? So you're going to get a 1 on the exponent of the x. So it's going to be a 1x to the 1, which is just plain x. Okay? And when we divide negative 15x squared, well, the x squared by x squared, that's going to cancel out the variable, right? Negative 15 divided by 3 is going to give me what, Allie? Negative 5. Very good. All right. And this is why I said we're going to keep that plus there. We have to factor this part here. Now we have the 10 minus 2x. What common factor do you see between the numbers there? 2. So we're going to have a GCF of 2 there. 10 divided by, well, there's no x here, so since there's no variable here, we can't pull out a GCF of the variable, so it's just going to be the 2 for the GCF. 10 divided by 2 is? 5. Negative 2 divided by 2 is? Negative 1, but since we're just talking negative 1x, it'd be negative x. All right, now, this kind of looks like the problems we were doing before, where we've got these two binomials here. Are these two binomials the same? No, not quite. But there is something we can do here. If I were to take this 5 minus x, and I were to divide by negative 1, that would be dividing both of those by negative 1, right? Which would make this negative 5 plus x, which could be written as x minus 5, which would be the same as this, right? So if I take an additional factor of negative 1 out of here, if I pull out a negative 1 and make this a negative 2 instead of a positive 2, then this binomial will be the same as this binomial, right? You want to make them the same so you can actually factor it. So we're going to pull out that negative 1, and we're not going to divide by negative 1 here. What we're going to do is we're going to have, this stays the same, 3x squared, x minus 5. This is going to become negative 2, because anytime you pull out an additional factor, you need to multiply it by the factor outside there. Negative 1 times 2 is negative 2. And then you have this becomes, whoops, x minus 5. Now that we have that negative out, we can factor out that common factor. So we're going to factor out the x minus 5 from both sides. Well, not both sides, from both terms here. And we end up with x minus 5 times the 3x squared minus 2. And that would be your final answer there. Here are some examples of items that need to be factored by grouping. So what I would do here is I would group these here. Now, don't be fooled by the fact that there's nothing in here. There is understood to be a plus here. Okay, looking at this first set, I see a common factor of 5 in the numbers and an x squared in the x's. So I'm going to say that the common factor is 5x squared. What's left here would be 15 divided by 5 would give me a 3. X squared divided by x squared would give me a 1, so I would end up with just the 3 here in the first term. Then negative 10 divided by 5 is going to give me a negative 2. And x cubed divided by x squared is going to give me just x. So that's factoring out the first part. I'm going to put a plus in between. Okay, so looking at the second set of terms here, I've got 8 and 12. This one doesn't have a variable, so it's the only common factor is going to be a whole number here. I'm going to say the common factor would be what? 4. All right, so I work with 4. So it's going to be a positive 4. 8 divided by 4 is going to give me a 2x. 12 divided by 4 is going to give me a 3. Now, notice how this and this have the same 2x here, the same 3, but we got the different sign in the middle. There's minus 3 and a negative minus 2x. To do this, I'm going to have to factor out a negative from one of these. I like to do it from this term, so I'm going to factor out the negative from here, which is going to make this 5x squared 3 minus 2x, the first stays the same, minus 4, because I'm factoring out a negative 1, and then this is going to become a negative 3 minus 2x, because when I factor out the negative 1 from here, it's going to make it a negative 2x and a positive 3, switch the order, and I get this. So now I can pull out that 3 minus 2x as the one factor. The other factor is going to end up with being what's left over, which is a 5x squared minus 4. This and this give me this. Moving on to number 20 here. I'm going to group the first two terms and the last two terms. I'm going to put a plus sign in the middle here, so that's a negative x there. The common factor in the first one here is going to be an 8. So I get an 8y minus 1. Dividing both of these terms by 8, I end up with y and a 1. Then I'm going to add the common factor between these two here would be a common factor of x. Dividing both sides by x there, pulling out my x, I'm going to have an x and be a negative 1 plus y. Now, a negative 1 plus y is the same as y minus 1. If I switch the order here, which I can because it's addition, so it's commutative, I will be able to pull this out. I end up with 8 plus x and y minus 1. That would be my answer there. Okay, on the last one here, I would group these. Okay, and the last one here, I would group these two and these two, putting a plus in between. Now, 18 does not go into 48 evenly, but 6 does go into both evenly, so I would have a common factor of 6 and n to the 5th. 48 divided by 6 is 8, so I'd have 8n, because n to the 6. Then we'd have a 3. N to the 5th would cancel out. These n to the 5th would cancel out. N to the 6th divided by n to the 5th gave me just an n to the 1. All right, now over here, I would find a common factor of what? 7. They both have a common factor of 7. So, and noticing how this is a negative 3, and this is a positive 21, and this is negative 6, and I'm thinking I'm going to have to factor out a negative 7. So although I had made this a plus here, I'm actually going to factor out a negative 7, which is going to make this a positive 8n minus 3, which happens to be the same as this here. Now that they're the same, I can complete the factoring by making this 8n minus 3, 6n to the 5th minus 7. And that is my final answer for factoring there.